Okay, in this presentation, I'm going to talk about the orthocenter of a triangle. The orthocenter, you'll need to make paper triangles so that you can, and then you cut them out so that you can actually go ahead and measure the altitudes, because this is going to be the altitudes from each side. So you cut your triangles out of paper. Maybe put them on cardstock or something so that they can stand up. And then you measure the altitude and you actually draw it on here. Okay, so you would lay down your plumb line. Actually, the way I did it even better is I made a line from the vertex that is perpendicular. So I use the corner of my ruler right there. That's a right angle, a measuring angle. So I have a line going from the vertex perpendicular to the opposite side, and if you recall, that's the altitude. I did that for all three sides, and where they intersect is the orthocenter. All right, and again, there's nomenclature cards that you would share with the children. All right, and then you could have them make paper triangles of all the triangles in the triangle drawer of the geometric cabinet, and have them find the orthocenters of all of the paper triangles. All right. Okay, and then the next presentation, actually the next presentation I've already shown you, is the centroid. That was the where all three medians joined. That was the first construction we did. All right, and here, this is again a different presentation. This is the circumcenter on page 163, and it is simply the intersection of all three axes. If you remember, the axes are the perpendicular bisectors of each of the sides. So we can say that this is equal to that. We can say that this is equal to that, and this is equal to that. And all these are right angles, perpendicular bisectors. Where they intersect gives you the, gives you the orthocenter. So let me just dig that up. And okay, and then we only have one more construction that we need to do, and that is going to come in the next video. One thing I want to point out about the orthocenter that I didn't point out before, and that is, where did my orthocenter go? Here it is. The orthocenter, if you remember altitudes, we had some that were internal and external. So if you have an obtuse triangle, you're going to have at least probably two, you're going to have two altitudes that are external to the triangle, which means that the orthocenter will be external to the triangle. All right, I'm not going to do one here for you. Take that on as your challenge. Take a, just draw a an obtuse triangle, and or even a right triangle would be interesting, because remember, the right triangle was where the altitude, two of the altitudes are actually the sides, the legs of the triangle for the isosceles right triangle and the scalene right triangle. So try those two. I've just shown you the acute here. All right, but like I said, for those two, your orthocenter may lie outside the triangle. So make sure your students go ahead and try those. All right, so we have the orthocenter and the circumcenter, and the next presentation will be the, what's it called? The incenter, and the incenter, you'll see, has to do with bisecting the angles. All right, so I will show you how to bisect an angle. All right, thank you.